Since humans first looked up at the stars, Mars has been more than a planet. It was a god, a mystery, a destiny. Today, that destiny seems within our grasp. But what if we actually colonize Mars? In this very decade. Mars, our next home. The planet is approximately half the size of Earth, with a gravity about 38% that of our planet, allowing for unique challenges and opportunities in colonization. Unlike the moon, Mars boasts a thin atmosphere primarily composed of 95% carbon dioxide and has a day length of 24.6 hours, making it more Earth-like in its temporal cycles. The history of Mars exploration began with missions like Mariner and Viking, leading to advancements with rovers like Spirit, Opportunity, Curiosity, and Perseverance, all uncovering the mysteries of the Red Planet. As we envision colonizing Mars, the presence of water ice at the poles and underground becomes a crucial factor for sustainability, hinting at possibilities for future human life. In the midst of an extraordinary era known as the space race, private companies like SpaceX are revolutionizing how we approach space exploration with innovative designs like the Starship aimed at enabling long-term colonization of other planets. As NASA propels its Artemis missions forward, aiming to return humans to the moon and prepare for future Mars endeavors, the anticipation builds around the Mars Sample Return Project and the Gateway lunar platform. Meanwhile, China's ambitious Tianwen program marks significant advancements in planetary exploration, while Russia's uncertain role adds an air of intrigue, raising questions about international collaboration in this competitive landscape. In the realm of private companies, Blue Origin and Axiom Space are paving the way for commercial space ventures, showcasing innovations that promise to make space travel accessible to a broader audience. This unprecedented era is further enriched by global collaboration with agencies like ESA-JAXA and emerging Latin American space organizations working together to push the boundaries of what humanity can achieve beyond our planet. In an age where technology evolves at lightning speed, we find ourselves questioning, are we truly ready for the next leap into space exploration and artificial intelligence? Automation has begun to reshape our industries, with robots taking on tasks previously managed by humans, while artificial intelligence makes our lives more convenient and efficient. Imagine structures rising from the Martian soil crafted by advanced 3D printing technology that utilizes local regolith, paving the way for sustainable living beyond Earth. At the forefront of Martian exploration is the MOXIE device, which promises to convert the thin atmosphere into breathable oxygen, crucial for future human missions. With innovations like compact nuclear reactors and solar panels, we are exploring new avenues for generating power in the harshest of environments, ensuring sustainability for our extraterrestrial endeavors. In our quest to sustain life beyond Earth, hydroponics and aeroponics agriculture offer promising solutions, allowing us to grow food efficiently in the most unlikely of environments. The journey to Mars presents real risks that astronauts must prepare for, spanning a duration of 6 to 9 months. They face significant challenges such as exposure to harmful radiation, which increases the cancer risk due to the limited shielding available in space. Microgravity poses serious threats like muscle atrophy and bone loss, forcing astronauts to maintain rigorous exercise regimens to counter these physical effects. The psychological issues of isolation and delayed communication with Earth add another layer of complexity, as crew members must cope with long stretches away from their home planet. Medical emergencies in space present unique challenges, as diagnosing and treating conditions must rely on remote support and innovative techniques like zero-gravity surgeries. To prepare for such scenarios, astronauts undergo extensive training simulations that mimic the harsh conditions they will face on their journey to Mars. As the spacecraft approaches Mars, the crew must work seamlessly together to ensure a successful landing, their training and resilience put to the ultimate test. Being on the frontiers of exploration, they embody the spirit of human curiosity and the quest for knowledge beyond our world. In the not-so-distant future, humanity embarks on an ambitious journey to Mars, where life takes on a new form in inflatable semi-buried habitats designed to withstand the harsh conditions. These shelters utilize the Martian regolith for radiation shielding, offering protection as we adapt to this alien world. Life on Mars doesn't simply rely on technology. It actively incorporates in situ oxygen and water recycling, ensuring sustainability in this new world. Astronauts move outside their habitats in specialized spacesuits, navigating the challenging terrain to gather samples and conduct research. Martian agriculture thrives within innovative greenhouses where plants not only provide nourishment, but also support life with essential oxygen. To combat isolation, astronauts engage in social interaction and entertainment aided by AI companions to maintain mental health during their long mission. In this new Martian society, community plays a crucial role in maintaining morale with spaces designed for social interactions and shared experiences fostering human connections. Amidst the challenges, moments of tranquility such as meditation help maintain mental health, reminding astronauts of their home even light years away. Terraforming has captivated the imagination, raising questions of whether it is science or merely fiction. The intriguing theories suggest releasing CO2 from regolith to thicken the atmosphere, while others envision orbiting mirrors and advanced plants paving the way for a new world. The timeline for such monumental changes spans centuries or even millennia, as experts explore alternatives like local terraforming with protective domes that foster life in harsh environments, demonstrating the innovative possibilities that lie ahead. As the quest for terraforming continues, dedicated scientists work tirelessly to unlock the secrets held within extraterrestrial soils, envisioning a future where humanity thrives not just on Earth, but across the cosmos. The journey of terraforming is filled with challenges and discoveries, as the merging of science and imagination paves the way for remarkable transformations, bringing us closer to the dream of a second home among the stars. In global discussions, scientists and visionaries unite to weigh the ethical and practical implications of terraforming, as the prospect of reshaping entire planets ignites debates about our responsibilities in the universe. In the vast expanse of Martian soil, a new frontier of opportunity emerges where questions about ownership, resource mining, and trade fuel the dreams of pioneers, eager to carve out their place in space. As artificial intelligence steps in as a regulator of this burgeoning economy, balancing labor needs and resource management, the vision of megacorporations rising on Mars becomes increasingly plausible. In this dynamic environment, the debate over private ownership versus the Outer Space Treaty rages on, as visionaries explore the possibility of a unique Martian economy, blending barter systems and cryptocurrency for transactions. With laborers adapting to their new roles and resources becoming the lifeblood of Martian settlement, the stage is set for an economic revolution, one that could redefine ownership and trade beyond Earth. As every drop of water and speck of iron becomes valuable currency, the vision of a self-sustaining Martian economy begins to take shape, sparking imaginations back on Earth about the true ownership of this red planet. Is it ethical to terraform another world? The moral dilemmas arise as humanity weighs survival against the preservation of untouched environments. The discussion of colonization circles back to historical imperialism, prompting critical questions about our intentions. With advancements in genetic editing, children born on Mars may represent the next stage of human adaptation. As we look towards Mars, we wonder if it will serve as a mirror, reflecting our past mistakes. A diverse team of scientists and ethicists deliberates intensely over the future of interplanetary colonization, grappling with ethical implications and the potential consequences for both Mars and Earth. The serene Martian landscape is starkly contrasted with images of Earth ravaged by deforestation and pollution, raising urgent questions. Will we carry our destructive habits to another planet? Children thrive within a biodome on Mars, their laughter filling the air as they explore the specially designed flora and fauna meant to sustain life. In a laboratory nearby, a geneticist meticulously analyzes DNA sequences, pondering the implications of human evolution in an extraterrestrial environment and the responsibilities that come with such power. Mars is no longer just the dream of a few, it's the next step, and maybe, just maybe, it's closer than we think. Call to subscribe, comment, and share. As we explore the challenges and possibilities ahead, the vision of a thriving Martian city becomes clearer. Science cooperation and the future of humankind rest in our hands. The journey towards Mars is not just about reaching a new world. It's about building connections and fostering collaboration. Together we can turn this dream into a reality. With every experiment and every shared moment, we pave the way for future generations. This is not merely exploration. It is the beginning of a new chapter for humanity. As we gather to celebrate our achievements and share knowledge, we illuminate the path forward. The possibilities are limitless when we unite for a common cause. Education and innovation will be key as we teach our children about both their new home and their roots. Together we will shape a future where Earth and Mars thrive in harmony.